guys, welcome back to our channel. This is Remy from Do and Learn. So today we are going to learn about how to simplify Boolean expressions using KMAP. Let's get started. So as you know, KMAPs are usually used to simplify or reduce the Boolean expressions of functions. So when we have a huge Boolean expression, it's a requirement to simplify it so that we can get a more efficient hardware, and it'll also be more portable. KMAP is really a structured method to solve or simplify the Boolean expressions, and also it's very efficient. So let's try to understand the basic structure of a KMAP. So let's say if the number of input variables in your Boolean expression is 2, let's call it as A and B, then the structure of a KMAP looks like this. It has 4 cells. So this is cell number 0, cell number 1, 2 and 3. Similarly, if the number of input variables inside your Boolean expression is 3, then the structure of your KMAP slightly varies. It has 8 cells this time. So I have 4 on the upper row and 4 on the lower row. Then suppose your input variables is 4, then obviously the number of cells inside a KMAP is 16. So let's say when I have 2 variables, then let me call those variables as A and B. So my KMAP is formed in such a way that my row headers are marked with the first variable A and my column headers are marked with the second variable B. So the first row header is A dash, second one is A, whereas the first column header is B dash and next one is B. So here A dash corresponds to 0, whereas A corresponds to 1 value of that variable. Similarly, B dash corresponds to 0 and B corresponds to 1. So when we have a complemented version of any variable, that is represented as 0. When we have a normal version of any variable, that is represented as 1. Likewise, when we have 3 inputs in your function, then we have a KMAP that has 8 cells in it. So when we have 8 cells, the row headers occupied by the first variable, A dash and A, as we had in your previous KMAP, whereas the column headers are occupied by the other 2 variables. So in this way, we have B dash C dash as the first column header, B dash C as the second column, BC as the third column, and BC dash as the fourth column. So if you represent in the form of zeros and ones, then this is represented as 0, this A is represented as 1, B dash C dash is represented as 0 followed by 0, because as I told you, when we have a complemented version of a variable, that is represented as 0. Here B dash C is represented as 0, 1, BC is 1, 1, BC dash is 1, 0. Similarly, when we have a function or a Boolean expression that has 4 input variables, then the number of cells inside your KMAP will be 16. As we can see here, we have 16 cells, and the row header is occupied by the first 2 variables, and the column header is occupied by the last 2 variables. So let my first 2 variables be A and B, and the last 2 variables be C and D. So this is how it is formed. A dash B dash is your first row header, A dash B is the second row, AB is the third row, and AB dash is the fourth row. So if I represent this with the form of Boolean values, so it is 0, 0, this is 0, 1, this is 1, 1, and this is 1, 0. In a similar fashion, we can even fill up the column headers. So this is 0, 0, 0, 1, 1, 1, and 1, 0. So hope you can understand the basic structure of a KMAP. We can deal with this in detail. So before that, we need to understand the common idea of a KMAP. So if the number of input variables for any function is k, then the total cells inside a KMAP will be in the form of 2 power k. Like you can apply, we have 4 input variables in this. So 2 power 4 is nothing else but 16 variables or 16 cells. That's what we have. So if we have 3 input variables, then 2 power 3 is 8. So 8 is the number of cells inside your KMAP. Similarly, if I have 2 input variables, then 2 power 2 gives me 4, and 4 is the number of cells inside my KMAP. So I have to select my KMAP according to the number of input variables what we have. Moving further, let's try to understand the internal details of a KMAP. So when we have a 4-cell KMAP, each and every cell corresponds to the row and column combination. So if I take the first cell is obtained with the help of row value A dash and column value B dash, which is nothing else but when I have A dash into B dash, that is 0, 0. So 0, 0 can be represented with the help of a minterm called as M0 or M0. So if you don't know what is a minterm and a max term, please refer my previous videos, which helps you to understand what is minterms and max terms. So coming back to this KMAP, so the second cell is highlighted with the help of a minterm M1. The third cell is M2 and the fourth cell is M3. So M1 corresponds to 0, 1 actually. So as you can see, the row header is A dash and the column header is B, which connects M1. So M1 can be represented as A dash into B, which is nothing else but 0 and 1 in forms of Boolean values. Similarly, we have M2, which corresponds to A, B dash, and I have M3, which corresponds to A into B. Or if you write it in Boolean values, it is 1 and 1. M2 is represented as 1, 0. Likewise, let me erase this part so that it's clear. An 8-cell KMAP is again represented with the help of minterms, but this time, since we have 8 minterms here, the arrangement is as follows. The first cell is M0, second cell is M1, third cell is not M2 but it is M3, and the fourth cell is M2. So your representation is 0, 1, 2, then you come for 3. Similarly, the second row is occupied by M4, M5, M6 and M7. Likewise, we can even map the 16-cell KMAP with the help of minterms. Since we have 16 cells, then the number of minterms starts from 0 and it goes to M15. So totally we have 16 minterms. Okay. So we have 16 minterms here. So if I map these minterms with the cells, so the first cell is M0, second cell is M1, this is M2 and M3. Then we have M4, M5, M6 and M7. So the first two rows is exactly same as an 8-cell KMAP. And the last two rows, I have to start with M7, which is given here. And the last two rows, sorry for that. And the last two rows, where I have to start from M8, M9, M10 is here, M11 is here. Then I have M12, 13, 14 and 15. You can take any cell for referring the Boolean values. Let's say I'm just selecting this M13. So M13 is formed by this row and this column. So if I combine those two, then M13 is A, B, C dash D, which is given as 0, 0, which is given as 1, 1, 0, 1. So 1, 1 and 0, 1's decimal value is actually 13, which corresponds to its minterm value. So this is how we map your KMAP. So let's try to solve a simple problem by simplifying a Boolean expression with the help of a KMAP. So let's say this is the given Boolean expression. So the given Boolean expression is in the form of minterms. So if you rewrite this, so f of a comma b is sum of the minterms m0, m1 and m2. So this is what is given. So from the given expression, you can identify we have two input variables. So when you have two input variables, then the KMAP will have 4 cells in it. So let's say this is a KMAP. Now let's start solving this. So the very first step is to identify which type of KMAP we can use for this problem. So we have identified that we will be using 4-cell KMAP. Now the second step, you need to map the minterms inside your KMAP. So let's start mapping the minterms. So the minterms that are present inside the question will be mapped with the help of the value 1. So M0 is present in your question. So M0, I mark it as 1. Now M1 is also present. I mark it as 1. M2 is also present. Then I mark it as 1. So the second step is mapping of minterms inside your KMAP. So let's move to the next step. My third step is to group my minterms. So when I want to group my minterms, I follow certain strategies. The first strategy is that I can group my minterms only if they are adjacent to each other. So what do we mean by adjacent cells? So adjacent cells are nothing else but neighboring cells which are either in a horizontal fashion or in a vertical fashion. I cannot have neighboring cells in a diagonal fashion. So identifying adjacent cells are nothing else but identifying your neighboring cells. So I can group my minterms if they are present neighboring to each other or if they are adjacent to each other. So the number of elements inside any group should be in the powers of 2. So what I mean by this, so I can have 4 elements, I can have 8 elements, or I can even have 2 elements, but I cannot have 3 or I cannot have 6 because 6 and 3 are not proper powers of 2, whereas 2, 4, 8, 16, 32 are proper powers of 2. So you need to first find the adjacent cells or adjacent minterms. Second one, you need to make sure the number of elements inside your group should be in powers of 2. So let's get started. So the maximum number of elements that can be grouped in a 4-cell K-map is 4, but 4 elements are not present here. I have only 3 elements. So I have to go for the next order, that is 2. So I have to group my elements in terms of 2. So first I will take this group. So let this be my group 1. Then I have only one minterm left out. I will take these two as another group. So you have to continue grouping your elements until no minterms are left out. And you can group a minterm which is not yet grouped along with an already grouped element. Okay, that's what we have done in the second group here. So the first group was formed with these two cells M0 and M1. Then we had M2 alone. So in order to group M2, we grouped it with M0, okay, because M0 and M2 are adjacent to each other. It is not possible for me to group M2 and M1 because they are diagonal in nature. So that is the third step. Now moving to the last step or the final step, you have to collect your groups and your final solution is that sum of those groups. So my group G1, I have to find the variable expression of G1. So G1 is formed with the help of these two elements in the group. So the matching row is A dash and the matching column is B dash plus B. So it is A dash into B dash plus B. That gives me A dash. Okay. Similarly, G2 is formed with the help of the row A plus A dash into the column value B dash. So I have to take my groups. If I want to express my groups in terms of the variables, then I have to multiply my row and column. So that's what I have done here. So adding G1 and G2 will give me the final solution. So f of A comma B is equal to G1 plus G2, which is nothing else but A dash plus B dash, because this will give me B dash. Okay, A plus A dash is 1. So the final answer is A dash plus B dash. Let's try to solve another example so that we can understand it better. Now in this example, we have 3 input variables. So when you have 3 input variables, you know that the number of cells inside a K-map will be 8. So as we have the 8-cell K-map here, let's start mapping the variables or mapping the minterms. So I have 0, 2, 5, 6 and 7. So M0 is mapped, M2 is mapped, M5 is mapped, M6 is also mapped, M7 is mapped. So step 1 is over. We have found out the number of cells inside a K-map, and we have step 2 is we have mapped the minterms. Now moving to step 3 where we are supposed to group your elements. So now grouping starts. I can group 8 cells, I can group 4 cells, I can group 2 or 1, but 8 is not possible because all 8 cells are not occupied here. So let me try for 4 group elements. So 4 is also not possible because I don't find any 4 cells which are mapped with the minterms and also adjacent to each other. Suppose if I had one here, then I could have taken these 4 cells, but since I don't have anything here, I have empty cell here, so I cannot group them into 4s. So let me try for grouping them into 2. So 2 is possible. So what I can do is I can take these 2 elements first. So let this be group 1. Then I can take these 2 elements. Let this be group 2. Now another way of grouping is your adjacent cells at the corners. That is also possible. So I can take this one along with this one. So that will give me a group of 2 elements. So this is G3. So let me trace back. So first group was M5 and M7. Second group was M2 and M6. The third group was M2 and M0. So you can have different groups according to the way you group it. So some might take, let me change the color so that, yeah. So some might consider grouping these 2 first. then they might consider grouping these two elements, then they might consider grouping these two. That is also possible. So you have to repeat this grouping process until all the minterms are grouped. So according to my groups, I have 3 groups here. So the total function is G1 plus G2 plus G3. So G1 is given by M5 and M7. So M5 and M7 corresponds to the row A and the column B dash C plus BC. So it is A into B dash C plus BC. So if you have two columns here, B dash C plus BC, definitely C can be taken as common here. So B plus B dash gives me 1. So ultimate answer for this one is A into C. So that is group 1. Now considering group 2, group 2 is obtained from M2 and M6, which is A plus A dash, that gives me 1 into B C dash. So group 2 is nothing else but B C dash. Group 3 is obtained from M2 and M0. M2 and M0 corresponds to A dash. So let me have that first, A dash into the column values are B dash C dash plus BC dash, which is nothing else but C dash. So that can be written as A dash into C dash. So finally, forming all the 3 groups, I get AC plus BC dash plus A dash C dash. So if someone might have taken M7 and M6 as a group and M2 and M0 as a group and M5 and M7 as a group, then they might get a different answer. But the outcome of all these solutions are always same. Moving further, let's take another example which occupies 16 cells. As you can see here in the question, they have not given us the variables, input variables. So we have to find out how many number of inputs would be there for the system. So in order to find out, just find the maximum element inside your minterms. So the maximum element what I have is 14. As you know that when you write the powers of 2, 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, and 2 power 4 is 16. So my 14 lies in between these two values. So I have to take the highest value. So the number of input element here is 4. So since I have number of inputs as 4, the total number of cells is 16 cells. So let's start mapping the cells first. So I have 0, I have 4, I have 5, followed by 8, followed by 10, then I have 12, followed by 13 and 14. So we can group 16 cells, or we can group 8 cells, we can group 4, 2 or 1. So these are the available options with us. So let's start with 16 if possible. But in this KMAPS, 16 is not possible, because if I have to select 16 cells, then all the cells should have been occupied with 1. But 16 is not possible here. So let me check whether 8 is possible. 8 is also not possible, because I don't have 1 here, or I don't have 1 here. So 8 cell or 8 elements in a group is not possible. Let me try for 4 elements. Yeah, 4 is possible. So I can take this as my first 4 element group. Let me call this as G1. Then I can take this as another 4 element group. So here M5 and M13 are new, whereas I am going to take M4 and M12 from the previous group. So this is G2. Then I have 2 more ones left out, M14 and M10. Instead of taking it as a 2, I can club these 2 and I can join with these 2. So this is possible because they are in the corners, right? As I told you in the previous example. So this is G3. So let me try to find out what is G1. So G1 is these 4 cells. So if you add all the rows, that gives you 1. Then into the column C dash D dash. So that is 1 into C dash D dash. So that gives me C dash D dash. Now taking G2. So group 2 is M4, M5, M12 and M13. So if I take the row headers, it is AB plus A dash B, which is nothing else but B, into C dash D dash plus C dash D, which is nothing else but C dash. Okay. Taking group 3, I have to consider M14, M10, M12 and M8. So I have to consider the last 2 rows and the first column and the last column. So when I consider the last 2 rows, it is AB plus AB dash, which is nothing else but A, into the column values C dash D dash plus CD dash, which is nothing else but D dash. So we have obtained all the three values or the three groups. So the final solution is G1 plus G2 plus G3, which is given by C dash D dash plus B C dash plus A D dash. So this is the final simplified expression. Hope it is clear. We will take one more example. So we'll be really fast here. We will start marking the elements. So 0, 1, 2, 3, 8, 9, 10, 11, 12 and 15. So we can group 16 elements, we can group 8, we can group 4, 2 or 1. 16 is not possible since I have empty cells. Let's check for 8. Yeah, 8 is possible because I can consider these 4 along with these 4. So this will be my group 1. So I've occupied 8 cells in my group 1. Then I'll check for 4 elements. Actually 4 is not possible because I have 1 here. I can either group with this one, and if I even take the corners, I don't have 1 here, so that's not possible. So I have to go with the 2 elements, so no other way. So I will take this one as my group. So let this be called as G2, and then I will consider this one as my other group. So this is G3. So 4 is also not possible. We have taken 2. So ultimately your final function is G1 plus G2 plus G3. So G1 is given by 8 cells. So I have to consider A dash, B dash and AB dash along with all the 4 columns. So all 4 columns, if I add, that will give me 1. So it is just A dash, B dash plus AB dash, which is nothing else but B dash. Okay. So considering G2, so G2 is obtained from M12 and M8. So that is given by AB plus AB dash, which is A, into C dash D dash. Similarly, going for G3, so it is again AB plus AB dash, which gives us A into CD. So that's the option here. So the final solution is given by B dash plus AC dash D dash plus ACD. So let's try to understand what are the different possible groups that can be formed here. We can form groups in this way. We can form even groups with the corner elements here. If suppose I have 1 all over these corners, then that can be taken as a 4-element group. That is possible. And suppose if I have 1s here, then I can take this as a 4-element group. That is also possible. So if I have 1s here, then all these elements can be taken as 8-element group. So likewise, you can form your groups based on your requirement, but the only limitation is that the number of elements inside any group should be in the proper power of 2. Okay, so it cannot be 3, it cannot be 6, it cannot be 9 or something like that. So it has to be in a proper power of 2. So either it should be 1 or it should be 2 or it should be 4, 8, 16 and so on. Okay, and the number of cells inside a KMAP is determined by the number of inputs to your system. So if I have n inputs, then the number of cells inside a KMAP will be 2 pi n. So that's it. Hope you have understood. So in this session, we have seen about KMAPs and how to solve or how to simplify a Boolean expression using KMAP. So thank you for watching this video. If you like this video, please share and comment, and also subscribe to our channel. So if you have any queries, please do email us. I'll meet you in the next video. Thank you.